Welcome to the Climax Academy Live. I'm Clark Turner, the Calder Technical Sales Engineer for the Calder products at Climax. In the video series, we're providing an overview of our test equipment. Today, we'll be discussing the Calder QUICKSET pressure relief valve tester. As usual, for Climax, environment with safety first is our priority. So we first want to always do a risk assessment. Anytime we're in an environment with industrial equipment, we want to have our safety glasses and we want to have steel-toed work boots. Those are standard personal protective equipment at all times. As far as the job hazard analysis or the risk assessment goes, we want to carefully look around our work area and make sure that there's no hazards. Things that we could come in contact with or equipment that we could come in contact with. So things to watch out for are trip and slip hazards. If you have cords or hoses or that type of item on the floor, in and around pressure relief valve testers, oftentimes it's water. And then we also have pinch hazards. So when I'm putting the valve in, I have a pinch hazard, so I want to be protective of my hands and not get them caught. So the other thing we want to pay attention to is the personnel that are in and around the area that the discharge of the valve is going to be discharging to. So we want to make sure that it's roped off or it's protected to keep people from just wandering through during the middle of a test. The last one I want to mention today is that when making adjustments to a valve that's on the test stand with pressure underneath it, we just want to make sure that when we go to do the adjustment, that the test pressure that's sitting underneath the valve during the adjustment period is low enough that valve's not going to open on us whenever we go to make the adjustment. So be cautious of that. There's provisions we'll get into in a little bit. So now that we're comfortable with our surroundings, we're going to proceed. So if you have any additional questions, please submit those to the Zoom Q&A at the bottom of the screen. And if I don't get to your questions, we will be sure and follow up with you after the session. So right now we have a short video and we're going to go to, and then when we return, we'll have a presentation on the machine itself. I'll go through the specifics of the machine, and then we'll have a question and answer time at the end.
"50 years ago, John Emmitte was a design engineer in the high-pressure industry, and he realized that companies were not testing valves properly. Back then, most valve testers were made in small shops and garages with weak designs, and they did not perform the proper testing of valves.
In order to sell an engineered product, you got to know the product. You got to know how to make it, and you got to know why it's made the way it's made, and you got to know functionality, what it does.
In 1984, Mr. Emmitte founded Calder Testers with the tagline, "We test valves correctly." Not long after, Calder began selling safety relief valve testers into nuclear plants and refineries, pioneering a new era for pressure relief valve testing. Today, you can still find these Calder testers in circulation, and their capabilities are being modeled across the industry as new standards.
It wasn't a machine shop, it was a manufacturing company that made specialty engineered products that they designed and engineered. And that's what made the fit.
Now, 40 years later and thousands of test systems sold and operating worldwide, Calder is once again redefining state-of-the-art in valve testing and leading the industry in the 21st century. The Calder QUICKSET Safety Relief Valve Tester can perform safety relief valve tests with unsurpassed quality and ease of use. A completely configurable product platform offering base machines of different tonnage with a full range of standard optional extras, providing more than 50 different configurations to choose from, providing ultimate flexibility.
The safety interlock senses test pressure and prevents the operator from releasing the valve while it's under pressure. Whenever there is pressure sensed, the interlock clamps down and prevents the operator from entering that test area, thus keeping the operator safe.
User-friendly foot pedal is designed to ensure the technician's hands are free to assist with valve clamping. The unique high-flow design of the CALDER QUICKSET is field upgradable, giving the user the ability to upgrade the vessel, the tubing, the seal plate inlet, and the clamping force, allowing operators to test a larger range of valves. Smart Test intelligent data acquisition system digitally indicates while recording tests for both seat leakage and set pressure, providing auto pass fail with the software and integrated laser bubble counter according to most major standards, including API 527.
The QUICKSET has the ability to do both gas as well as gas over water, allowing the owner-operator to test both gas as well as liquid safety relief valve. The configurability of the QUICKSET is really what's unique in this design. From how you can order it from the factory to how you can configure it after you purchase it. Many of these options can be done in your shop after your initial order. All the CALDER products are manufactured in the United States at our Newburgh facility.
CALDER products are backed with an industry-leading 2-year warranty with a full range of standard accessories and field upgrades. And when faced with unique challenges, CALDER's engineering team is ready with unrivaled custom solutions. No other valve testing brand can grow and evolve with your business like CALDER.
Welcome back. I hope you enjoyed the video and it provided you sort of a background on where CALDER's been, where we came from, and where we're at today. To start with, I'd like to thank our product development team and our product engineering team for developing quite a versatile test stand. I think after today's presentation, you should be quite impressed with it as well. So with that, we're going to start with the QUICKSET. The unit to my left is a best-in-class, compact, rugged, modular SRV tester that provides mobility and industry-leading value. Hopefully by the end of today, you'll be able to see how all that value is imparted into the machine. This unit can test, set, and certify pressure relief valves up to 6,000 PSI on not only gas, but can do liquid. And with the right attachments, we also can provide vacuum breather valve testing from full vacuum up to 100 PSI. This is a completely configurable product platform offering several base machines based on your application, your needs. And then we can build upon that as either your needs change or the product that you're testing or running across it can change as well. So it's kind of a flexible environment. Similar to our HydroPro console is basically as you can build it to as your needs, and then as your needs change, then this can be upgraded as well. So the base platforms have different tonnage clamp force and different feed range for the inlet feed for the test port. So we have a range of standard, optional extras that provide more than 50 different configurations. So this thing is fairly modular. So, up to 50 combinations of things that can go together that you can choose from that will provide you the ultimate flexibility that can be purchased either at the time you purchased the machine originally, or it can be upgraded at a later time. This machine is an industry first. It's standard field upgradable clamp force options from 30 to 60 tons. And where that comes into play is how much clamping force is needed to hold the valve to the test port as you put the test pressure to it. So if the valves are small or low enough pressure class, then the tonnage can be low. But as that pressure or the valve size or the combination of the two get high enough, then 30 tons is no longer going to be adequate to hold those valves down, and then you won't be able to test. So we can go up to 60 ton. There's field adjustable. So it's a tremendous, it's an industry first option on that as well. So the other part of the field upgradable is the test vessel size and the seal plate inlet size as well. We start off standard with up from a 1 gallon vessel and a 3/4 inch feed. And we can upgrade to a 2.5 or 5 gallon vessel and a 1 inch feed as well. So again, the standard base configurations is 30 ton up to 10 inch valves. test 6,000 PSI gas with a 1 gallon vessel and a 3/4 inlet connection. So, and then we can go on up to a 60-ton clamp for up to 16-inch valves. They can test up to 6,000 PSI gas, 2.5 gallon vessel and a 1-inch inlet. So we have 4 different combinations in those ranges. So that's a min and a max. So you can size based on your application. All systems have the following safety features. So Climax is very important, safety is very important with us. And so one of the safety features that we offer with all of our machines is a mechanical safety interlock. Now the mechanical safety interlock is here. This valve handle is the controls for the hydraulics. So I can close it and build pressure to hold the valve in place, or I can release it and I can open the valve and release the hydraulics and if I need to reposition the valve, or if I'm going to change the valve to the next valve, or once I'm done testing. So the concern with typical clamping style test stands is that you can release this while you have test pressure underneath. So we developed a safety interlock system. So once you get the valve positioned and you start applying test pressure to the valve, we have a mechanical interlock that's going to lock this handle in place, and then it won't be able to be released until that pressure's been removed. We have two different indicators. Another one is a pressure light that will go on once you have test pressure. So in the combination of the two, you can tell whether you have test pressure underneath the test valve or not. So but another safety feature is the e-stop. This is basically when all else fails and you hit panic mode, you don't know what to do, and you need to release the pressure from the system, you can slam this down and it'll release all internal pressure and not allow additional pressure to be built. So that's kind of a worst case scenario. For our test stands, we can't allow the valve to be tested without what we call an operator presence switch. And so that's, in this case, it's a button that has to be pressed in order for me to take what stored pressure I have and go to the test valve. So in order to run the test, as I'm adjusting my regulator, I have to have this we call it an operator presence. So you have to be here to be able to make the test run. So those are standard product as it comes. And this unit here is actually loaded with quite a few features. The other one that comes standard is a splash shield between the test stand and the control console. And so it's got a plexiglass window that you can see. But and so that's our standard setup. Now we have several options. The first option that's most common to be added is adding a water testing circuit, and what comes along with that is a catch basin to catch the discharge of the water testing. And so that circuit is here. And so we can fill the vessel, we can vent the vessel right here prior to applying the test pressure. So this is a water or air over water test setup. Very simple to add. Again, if you buy it as a gas only test unit and then decide you want to add water capability, it's a pretty simple upgrade in the field. Another option is to add vacuum testing. So we have a vacuum table, and then we also have a complete circuit here for testing pressure vacuum vent valves, any vacuum applications. So that's an option as well. Mobility. This unit is really designed to be mobile, and so if you look down on the bottom, you'll see that this is actually mounted onto a frame, and that frame is forkliftable. So it allows you to pick the complete unit up and go set it into a container, a trailer, back of a truck, whatever's needed for mobility. We do recommend you bolt it down to test, especially as the valves get bigger and bigger. The reaction force tends to be an issue, but it allows you to take it and move it from one location to another as needed. So if you do a lot of field work, this is a great option. That, or you can mount it into a trailer, take it to the field, and then when you come back, you can pull it out and set it back up in your shop. So we have the vessels, the test vessels. They come from 1 inch to 2.5 as standard setup. They can be upgraded up to 2.5 or up to 5 gallon vessel upgrade. Very simple change out. So that can be done as well. Oftentimes where that comes into play is either the larger valves or when you're testing for liquid, you want to be able to put more and more water into the vessel and give you longer test frequency between having to refill the vessel. So another option is a digital gauge upgrade for testing. This particular unit has a max setting, so you can, when you're running your test, you can check it to see what the maximum pressure was or determine what your set pressure is on your valve. So as far as the air or the test gas that's needed to run this unit, we have a couple of options. We have a fitting on the back, so if you have nitrogen bottles, you can obviously take and regulate down nitrogen to the inlet up to 6,000 psi and test all day long that way as well. If you want to put this into a container and take it to the field, we have an internal booster pump, and to hear it run, this unit's set up for that. And so basically what I'm doing is able to take shop air, 100 psi shop air, and then build up high pressure test and store it into a vessel that's mounted onto the back. So I can get up to 6,000 psi. It'll take a little bit to get there, but if I'm remote or away from standard shop environments, this gives me a really, really upgradable field option to allow me to produce those high pressure test capability in the field as well. So another option, if your application is in a shop environment, we also offer a 6,000 psi compressor with a dot bottle configuration for accumulation. So you can build pressure into the accumulators and then feed off the accumulators to feed the vessel as well. So there's a couple of options, and again, it really comes down to your application as to where you intend to use it, as to how we would recommend configuring a machine for your best needs. So one of the options is we have a data acquisition system that comes along with this that can monitor and record the pressure for testing. And it also comes with a bubble counter for seat leakage, the API 527 seat leakage capability. The particular data acquisition system also provides a back pressure test capability, bellows testing, and also just back pressure testing directly. So we have 4 different tests that the data acquisition system can do right out of the box. So for threaded inlet valves, the test plate itself is set up for flange valves. So if you have a lot of portable or threaded inlet valves, we sell a series of MPT adapters. They're MPT male and female all in one adapter plate with an adapter threaded from 1/2 inch up to 2 inch. So that's a pretty easy combination that goes to the field as well. So, and then the last is we as standard comes the splash shield here, but we also have a safety enclosure that can go 360 surround of the test port. So with that, I think what I'm going to do is demonstrate how to clamp a valve and how to test a valve. So one of the options that we have is typically when I'm over messing with the clamp table, I'm away from the controls on the hydraulics. So the easiest solution is we have a foot pedal that comes out and allows me to put a low pressure clamp pressure onto the valve so I can hold it in place until I can come around and properly clamp it. So when I install the valve, I basically want to install it onto the test port, slide my plates up, make sure I'm centered on the test plate, and I want to use a foot peg to slowly build pressure and raise the ram to trap the test valve between the clamp arms and the seal plate. And I'll feel that when the clamp arms grab the valve and it stiffens up, and that's all I need to do is just get to that point, and then I can come around and determine how much clamping pressure is going to be needed to hold the valve for my test. And as you can see, it's kind of loose, and when it actually traps, it'll become stiff, and I'll be able to feel it with the valve. This particular valve is set at 400 psi, and so as you can feel right now, that's rigid. So with a 400 PSI, I know it's a 1-inch inlet valve. So I can come to my chart here, and I go to 1 inch. And really all I need is a 100 PSI clamping pressure to hold the valve for this test. So I'm sitting less than 100, so what I'm gonna do is adjust my regulator to provide me the 100 PSI clamping force. And so there we sit. So the valve's clamped in place and it's ready to be tested. So now all I need to do is ensure that I have enough stored pressure in my vessel to provide test fluid. I zero my gauge. I have around 1,500 PSI stored at the moment, so this valve set at 400 PSI, that should be more than adequate for me to get tests out of it. So with that, what I'm gonna do is go ahead and run a test. So normally what we would do is come up to about 3/4 of the set pressure at whatever speed or ramp rate I want to. And then from there, I'll start controlling. I'll control the ramp rate from about, in this case, with a 400 PSI set valve, I'm going to take it up to about 300 PSI and then start controlling the ramp rate from there. So I'm sitting right at 300 PSI now. So I'm going to start bringing it up. So I'm sitting at 330, 335, 340, 350, 360, 370, 380, 390, 400, 410, 415 PSI is where the valve lifted. Now it closed and reset. I released the valve at 243 to give us some indication of that difference between opening and closing. So as you can see, as you can hear from the test, there's plenty adequate pressure to get it off the seat, and then it holds the valve open for a while. So again, this particular unit is set up with 5 gallons and a 1-inch feed line, so there's adequate volume to pop and test that valve. So, is that it? Okay. So with that, let me isolate the test stand, and then we'll go to the question and answer period. So,
what HP pressure source options does Calder offer?
okay, so the question is what high pressure test sources does Climax or Calder offer as an option? And again, it's a shop environment. It's a compressor, a 6,000 PSI compressor with 2 dot bottle accumulation stored that can feed. The customer can always rent, or if they have nitrogen bottles themselves or compressed air, they can use those directly. And for field use, we also offer a booster style pump that like this unit set up with allows you to take just standard 100 PSI shop air or compressed air from a portable compressor, and you can build that pressure up and test as well. So good question.
Can I operate the machine without the PC and software?
Can I operate the machine without a PC and software? And the answer to that one, most definitely. Right now, we don't have the DOS attached. So this machine is running, the safety interlock is still engaged. I have test pressure underneath it. I don't know if you can see the light, but the safety light is on as well. And so I just tested a valve. I don't have a computer attached at all. So it's a mechanical interlock. It does have electric needs for the light indicator. So outside of that, there's no computer controls, no. If the computer goes down or if I have electronic issues, an instrument or component goes out, it's not going to keep me from testing valves.
Do you have recirculation system for water options?
Do we have recirculation system for water options? Good question. And we do. We have a standard recirculation system, a 35 gallon, 65 gallon, 125 gallon system. The option would be to capture the water. That would be in a separate pallet. and it needs electricity to drive the pump. But we could certainly feed this system with that unit, and then we can capture the discharge from the test, and then we would have to install a pump and return the water to the recirculation tank. But yes, it certainly could be fitted with a recirculation system.
Does the stand produce enough volume to get a pop on a 6-inch inlet relief valve?
Does the stand produce enough pop for a 6-inch valve? And the answer is, if it's configured properly, yes. A 5-gallon with a 1-inch vessel will definitely get a 6-inch valve up off its seat. It's not going to blow it open. It's not going to leave it open for long, but it will not set the simmer point. It will definitely set the set point.
In the video, John Emmitte says people weren't testing valves correctly. What did he mean, and do you see evidence of that today?
Great question. In reference to the video prior to this, as Mr. Emmitte had mentioned, that people were not testing valves properly, and I believe he was alluding to they weren't providing either enough volume to the inlet to test it, to get the valve up off its seat to find the pop point. They were setting the simmer point, and so as designed, these spring-loaded valves, metal seated, they're not guaranteed to be seat tight above 90%. In fact, API 527 allows them to leak above that point, so they can start leaking at 90 to 100%. So if you don't have enough volume and enough feed to the test port, then what ends up happening is the volume leaks out before you can get enough to get it to pop. So often when you would see field test stands, they were setting the simmer point. They were trying to determine where was it that it was starting to leak, as opposed to where it was at testing. You know, a common method used to be is they would run the lower ring up and try to close up that annular space to try to use that. There's some discussions as to whether that affects the accuracy of the test or not. So with that, you provide enough volume, then you don't have to do that.
How does clamping tonnage affect the range of valves that can be tested?
Good question. The clamping tonnage and the valve size also come into play with the third variable, that is the set pressure. And so when you start talking about API 526 style valves, there's a sliding slope from 4-inch on up that they don't go on up to 6,000 psi. Now, pilot valves may be a different story, but the clamp pressure's got to be enough to hold the valve size, so up to 10-inch or up to 16-inch, and then the set pressure goes in combination. So with those two, it's the amount of clamp force that's needed to hold the test valve to the test port while the valve's turned. So when you look at the chart that we have here, we have the valve size along the column, and then the rows, and then the columns are set up for the test pressure. And so it's going to come down to, if you have a 10-inch valve, is it a class 150, class 300, class 600? What is the range, and then what is the set pressure of the valve? Typical example, when you get into the moisture separated reheat valves, they're a 300 inlet flange, but that could be up to 740 psi, but the set pressures are usually 400 psi and less. So it's going to matter as the set pressure, the nameplate set pressure, and the flange inlet size is going to dictate how much clamping force. So we offer a range. So again, from 30 to 60 tons, and we can cover a really broad range of valves just with that range of clamping pressure. So good question.
Can you walk through the safety interlock again, please? And how does it work and keep us from launching a valve? Certainly.
So let me take the opportunity to bleed the pressure off. And I don't know. Let me demonstrate. Okay, sorry for that. So with no pressure, no test pressure inlet, I can release the clamping return valve. I can rotate this and release the clamp pressure to go back to the reservoir. When it's closed, I got the valve positioned properly. I've got a mechanical interlock that's going to extend and lock this handle in place as soon as I get test pressure. So right now, I don't have any test pressure. I don't know that you can see it, but there's no interlock at this point. But when I engage and I start to build pressure, as soon as I get to a minimal amount of pressure, in this case it's 15 psi, now that interlock is encased. So now the interlock is engaged, and I can't, with only 15, I don't know if you can see that, but there's 15 psi on the system. So it's a minimal amount of pressure to engage the test stand. So the test light is not on yet. It will go on around 50 psi to indicate that it's even higher. So as I go on up in pressure, the light should come on. And this particular one goes on around 40 psi. So the light should be lit. And so I have two indicators that tell me that I have pressure underneath the test valve. And the first one is the light being on, and the second one is the safety interlocks engaged. So good question.
Can I purchase separately and use the Calder testing software and bubble counter on my old testing?
Good question. The data acquisition system is independent of the unit that it's applied to. In this particular case, we've packaged it such that it will bolt on to the cabinet inside. So it obviously we have other options that would be a better suit for that. But yes, you could actually take the unit that's used for this machine and use it on others as well. If you have transducers, you can place a transducer external to the machine and attach it right to the same data acquisition system. So good question.
How does Calder set the systems up? You provide training, and what about helping to get system installed?
Great question. We have a commissioning that's usually discussed at the beginning of the purchase. And so identifying the utilities that are needed to connect to the unit, being air, being electricity, be it water, be it a drain. So those have to be connected to the machine prior to running. And then whatever your test fluid, where that's going to be coming from. So we're going to have to connect it from either your bottles or a compressor or whatever. So there's a commissioning that says, we would ship the machine to you, have you connected up to the utilities. We can provide you guidance as to what needs to go where. And then we also provide training. So the first day of training is first thing we do is come in and make sure the machine's been connected properly to the utilities, and then we proceed on with testing. So yes, we provide training as well. We typically is about 4 people a day, and it really depends on the level of the personnel that's being tested. They're being trained. If they're a fully test certified technician or personnel that knows how to test valves, and we just need to teach them how to use our machine, then that's an easier training than it is if I'm trying to teach from scratch. So we kind of play that. And how long the training is going to take, that's going to be up to the quantity of people and the level of their knowledge and expertise. So the other option that we have is an annual or biannual maintenance evaluation. We can come in and evaluate your machine on a regular basis to make sure that it's performing properly. So that's another thing to discuss with your area sales managers at the time of purchase, is to consider having us come in once a year and check to make sure all the circuits are functioning, make sure, clean the machine up, make sure filters are clean, make sure the pumps are set properly, make sure the interlocks are working properly. So we offer that as well. So good question.
Any more questions?
Are there any more questions? Okay. So if not, if I didn't get to your question, or if you have a different machine that you would like to ask us about, please submit to askcpmt@cpmt.com. We'll be sure and get back to you. So With that, I want to thanks for joining us, and we'll see you next time.